All right. So last week we talked about section 9.5 and how to apply trigonometric ratios. So this week what we're going to be covering is going to be section 9.6. Again, it's going to be applying trigonometry and as well as their ratios to problems that might be a little different than what we covered last week. So it gets today's standards is going to be using trigonometric ratios and the Pythagorean theorem to solve right triangles in applied problems. That's the first one. And then the second standard that we have is deriving the formula A equals 1/2 A times B times sine of C for the area of a triangle by drawing a line from a vertex perpendicular to the opposite side. That is a lot of words. Basically what we're doing is we are just finding certain angles and side lengths in order to find the area of a triangle when you're not given like the base or the altitude for it right off the bat. So that's basically what these standards are saying, just so that way you can get like a heads up of what we're doing today. All right, so the main part of this is going to be angles of elevation and depression. So as you look up at an object, the angle formed between your line of sight and a horizontal line is called the angle of elevation. And an angle of depression is the angle formed by a horizontal line and an observer's line of sight to an object below the horizontal line. So angle of elevation, whenever you're looking out at something, and if something is up in the air, that's the angle of elevation. So if you have to actually look up at it, that's the angle of elevation. And then the angle of depression is if you're kind of like looking out, but that object you're looking at, if you have to like look down at it, that's going to be the angle of depression. So elevation, depression, that's kind of like what they're referring to there in that point. Let's see here. Yeah, that's kind of just like what we talked about there. All right, okay, so this is the part that like I want you guys to like, write down in your notes. So often the only way to measure an object is through the use of indirect measurement, which involves using similar figures and proportions to measure an object. In these cases, you measure the object by measuring something else. Indirect measurements use special types of angles. An angle of elevation is the angle formed by a horizontal line and an observer's line of sight to an object above the horizontal line. An angle of depression is the angle formed by a horizontal line and an observer's line of sight to an object below the horizontal line. So this is what it's kind of going to look like. So if we have this image here, so angle of elevation, again, that line of sight, you're looking up at an object, and then that's just the horizontal line that they were talking about. So again, angle of elevation is going to be that normal horizontal line, and then that line of sight is going to be what you're actually like looking at, like to actually look at the object. And then angle of depression. So in this case, it's going to be the woman up on the balcony looking down at the woman underneath the umbrella. So the horizontal line, again, is going to be that orange dotted line. So what would typically be right out in front of you. Angle of depression, it's going to be the line of sight looking directly down at the object or whatever it is the observer is looking at. So that's I like that picture just because it gives kind of like more like a real world application to what it's referring to. All right, we can go ahead and move on to an example here for this. Okay, so drones. Rakeem, I think that's how you pronounce it, is flying his drone at the park. He spots the drone at an angle of elevation that he estimates to be 30 degrees. The remote control tells Rakeem that his drone is 102 feet above the ground. If Rakeem is 6 feet tall, how far is he from the drone to the nearest foot? So the first thing that we're looking at is what do we know about the information with the triangle and the information from the paragraph. So the first thing that we can do is we need to find the height of BC. This is going to be an example that I kind of like cover with you guys before we actually move on into other ways to apply it. So whatever I write down, I really appreciate if you would write it down just so that way you have something to look back onto for an example. So we do so earlier, like last week, we had our triangle and we had the height or of a side that we would then use to solve for an angle or another side of a triangle. But this time, right off the bat, we don't have a specific side length of the triangle. What we do have is how tall the drone is up in the air. In this case, it is 102 feet. So that we are going to be using to find the side of that side. Here's what I mean by that. So if we know that the drone is 102 feet above the ground, but we also know that Rakeem is 6 feet tall, we're going to take the 102 feet and we're going to subtract 6 feet from it, because we are focused on that side right there. We're focused on the length of BC, the side BC. In order to do that, we have to take away from the overall height. So we take that 102 and we subtract 6 from it. Again, drone is 102 feet in the air, but we also know that Rakeem is 6 feet tall. So we're taking away 6 feet to find the side length of BC. That's our first step. And when we do that, we are going to get 96 feet. For the first part of it. Yeah, I wish it was that easy. I wish it was that easy. So again, we're taking what we know from the triangle and from the information from the paragraph, and then we're finding out the length of a certain side. So again, we take the 102 feet and we subtract 6 feet from it to get the side of BC, which again is going to be 96. So I'm going to go ahead and write 96 right there, just so that we have something to look back on. And then from the theorem that we were using, well, no, the theorem doesn't apply to this one. We're going to be using sine for this one, and here's why we're going to be using sine. I'm going to go ahead and erase this just so I have some room. So like I said, we're going to be using sine of angle A because we know the degree of angle A, so we're going to be using angle A for our ratio. I'm just writing this out like just as a formula, just so that way we can kind of see like what we need to do to set it up. We're using sine because, yeah, that's why. Yeah, trip myself up. The reason we're using sine, again, because we're trying to find the distance between Rakeem and the drone. And the reason we're doing that, or not the reason, but because we're solving that, that is going to be our x. So if we have 96 feet on the opposite end of the angle, and then we're solving for x, or in this case, it's going to be the hypotenuse, what ratio are we going to be using? We're going to be using sine, because opposite over the hypotenuse. So that's why we're using sine. So again, we're going to set that up. Sine of A is going to be the opposite. So the opposite is going to be that BC over top of AB. That's the ratio we're going to be using. And then now all we need to do is now we need to plug in the information that we know. So if we know the angle of A, so we have sine of A, in this case it's going to be that 30 degrees, so put 30. And now we're going to fill in the ratio. We know what BC is because we just subtract 102 from 6, so now we're left with that 96. And then it will be over top of AB, but that AB is what we're solving for. So I'm going to plug in x for it. Any questions how we got there, why we chose that ratio or anything like that? Feel good about it? Okay. Now this is where algebra comes in, because now we have to solve for that x. Last week there were a lot of examples where we had the number on the bottom, so all we do is like just bring over that number and then we just plug everything to the calculator to solve for like that top portion of it. In this case that is not, because x this time is now on the bottom. So now we have to do something, we have to do a couple more steps, but it's not like completely wild, I promise. The first thing that we do is we need to, in this case, we need to get 96 by itself. So what for last week, what did we do to get x by itself? What do we do with the bottom number? Exactly, we're going to multiply it over. We're going to do the same exact thing, just this time we're going to do it with the x. So go ahead and bring that x over. I'm going to go ahead and erase this just so that way I have room again. Does everyone have this written down before I move on? Okay. But yeah, like I said, we're bringing that x over because because we're dividing, so we got to do the opposite, which is going to be that multiplying. So again, we're bringing that x over. So it's going to be that x of sine of 30 is going to equal the 96. Now going back in algebra days, if we are multiplying something together, in order to get rid of it, what are we going to do with it? Divide, exactly. So in this case, what we're going to be doing is we're going to be dividing by that sine of 30. So it's going to look like this. So x is going to equal that 96 divided by sine of 30. Now in the, I'm trying to think like within the calculators, I'm trying to think exactly how to do this. Because calculators don't like to do the order properly whenever it solves. So here's what I want you to do. Go ahead and get your calculators out now. This is what I want you to type. I want you to type in 96 divided by, and then I want you to put a parenthesis. And after you click that parenthesis, I want you to type in the sign button that's on the calculator. Type in the number 30. And I want you to put 2 parentheses right after that. Because what that's going to do is because using like the PEMDAS rule, parenthesis is going to be the first thing that we're doing. So the calculator is going to realize that. It's going to solve for sine of 30 first, and then it'll do the 96 divided by sine of 30. So that's why we're using the 2 parentheses. And then again, so in the problem, we're solving to the nearest foot. So when you plug that in, I think it was like roughly like 192. Is that what people were getting? If you did not get that number, please raise your hand. I will come by real quick and like just make sure that you typed it in correctly. Because this is where it does get a little tricky whenever you're using the calculator, because it's very particular about where we need to put the parentheses for it. But yeah. So 192 feet. That is a very terrible feat, my bad. But 192 feet, that is going to be our answer for it. Again, because we're solving to the nearest foot. Are there any questions on that, seriously? Like I said, it was like a couple more steps than last week, but I just want to make sure that we're all like on the same page. Okay. But yeah, for this one again, this is the concept we're going to be applying for this entire section. You take what we know. In this case, we were given the overall height, but we didn't know the actual height of the triangle itself. All right, but everyone got this written down before we move on? I'm not seeing anyone writing, so I feel like I'm good. Okay, cool. All right, let's go ahead and move on here. All right, our second example. Let's see here. Yeah, okay. So this one, I'm still going to go like over it, but then I might ask everyone else to kind of like chip in just so that way I can see that kind of understanding this a little bit. And then after that, I think I have one more problem and I might have you solve it. That way you can get some extra practice. Okay, so we're at a zoo in this case. A sign at the chimpanzee enclosure tells Rajesh, I think, that the highest platform is 30 feet away from the observation area. He tilts his binoculars to an estimated angle of 15 degrees to see a chimpanzee on the platform. If he is 5 feet tall, how tall is the highest platform? We are rounding again to the nearest foot on this one. So we know that it's 15 degrees. We know that we have that so far. We know that it's 30 feet away. And then now we need to find out the highest platform. So the first thing that we got to do is we need to find our ratio. We need to take what we know. We also need to apply what we're trying to find out. So in this case, what are we trying to find? How tall the platform is. Okay, so if we're trying to find how tall the platform is, I was going to ask what side it is, but there's not letters in it. Okay, here, hang on. Okay, so if we're trying to find the height of the platform, what side are we going to be finding? BC, exactly. But yeah, So BC, I went ahead and just put an X there just as a variable. That way I wouldn't have to write BC over and over again for it. So again, if we know that if we have the 30 feet, the platform is 30 feet away, and we're trying to find the height of the platform, what ratio are we going to use for this? What? I think I heard it. I thought I heard it. Exactly. Okay, so why tangent? So exactly, yes. We're using tan. So we have our angle A. It's going to be that opposite over the adjacent. That is correct. So we have our opposite. It's going to be that. It's going to be BC over top of AC. So we know the information we took into the account, the information that we know, and we also took into account what we're trying to solve. That's how we get tan. And now we just start plugging in that information. So we have tan. What number am I putting in the A spot? 15, right, because it's at 15 degrees. Okay. And then now what is my ratio going to be? Yeah, exactly, x over 30. Now this problem's a little different than last time because now the x isn't on the bottom. We don't have to do all the dividing and stuff like that. So the next step, what's the next step we're going to do? Exactly, multiply each side by 30. We're going to bring that 30 over. And that is going to give us 30 tan of 15. That's going to equal x. Go ahead and plug that part into your calculator, the 30 tangent 15. 8.03. 8.0. Okay. So here, I'll write that right here. All right, let's make sure here. All right. Okay. Let's think about this here. Okay, so is my answer going to be, in this case, we have to round to the nearest foot. So is my answer going to be 8 feet? Are you sure?
No, it's going to be 13.
Okay, so why is it 13? Are you sure? Are we sure it's 8? Remember what we did last time? Last question that we had the 102 feet total. Exactly. We're going to add the 5 feet because we got to think about Rajesh right there. He's 5 foot tall. And so all we did was we just solved for the side of BC. Now we have to find the overall height. So we add the 5 feet to the 8 feet. Answer is going to be 13, or in this case, going to be answer B. Yeah, this one was interesting. It was a little tricky because it looks so easy. We just solved for side BC, but we got to take into account the other parts of the problem to find the overall answer. But yes, good catch on that. That's why I asked that. Wanted you guys to think about that one. But are there any questions over that? Again, it's nothing like completely new. It's just adding a couple more steps as well as pieces of information from the paragraph from the problem. It's just, are there any questions on that? No? Okay. Everyone have this written down before I move on? Okay, cool. All right, so now I have a problem that I'm going to have you all work on. I'll give you like a couple minutes for it, and then when I see like people are done, I'll go ahead and go over it, and then we can just move on to another example. So what we have here, we did extra example 1. No, come on, there we go. All right, there we go. Yeah, okay. So for this one, we're at a concert. Rodrigo is seated in the top row of the concert venue 250 feet away from his favorite drummer. If the angle of depression to the drummer is about 40 degrees and the band is performing on a 6-foot platform, at what height is Rodrigo sitting? So for this one, what we're doing is we are finding to the nearest foot. And what we're trying to do is we're trying to find, hang on, let's see here. Okay, so we're finding how far away Rodrigo is seated from the floor of the venue. So go ahead on this one. I'll give you like a couple minutes to solve it. If you have any questions, let me know. I'm just gonna be like pacing down through here. I turned my mic off because I was going to route and I forgot to turn it back on. All right. Gotta go back. There we go. Oh no, that's the wrong one. There we go. Okay. Let's see here. Good to move on. Okay, so angle of depression, kind of like what we worked with last time. This one, I know when I was going over it, I got a little tripped up, but I think I solved it in a good way, so hopefully I can relay that information to you guys. Okay, so again, we're using angle of depression. In this case, we are sightseeing. So Cottonwood, Idaho's Dog Bark Park Inn, say that 3 times fast, is a popular tourist attraction featuring a hotel in the shape of a 30-foot wood-carved beagle. Pedro looks out the window 30 feet from the ground and spots a fire hydrant on the ground at an estimated angle depression of 40 degrees. What is the horizontal distance from Pedro to the hydrant to the nearest foot? Okay, yeah, that was a mouthful. All right, but so we are given the 40 degrees. We'll use it. There you go. So we're given that 40 degrees angle depression. So then the first thing that we need to do is we need to make sure that everything is similar. So we need to look at some of the angles that are present. So in this case, we do have one angle of BAC. Now I hate assuming because I never want to assume just based on a picture, but in this case, we have to assume that angle ACD is congruent to BAC. The reason they're congruent, why are they congruent? Yeah, that is, yeah. Alternate interior angles. Yeah, but no, that is exactly correct. Because we have a 90-degree angle here, we have to kind of assume that if it's directly above, we have to assume at that point that is also a 90-degree angle, or because they're parallel. Yeah, they're parallel. Because of that, we have alternate interior angles. We know that angle ACD is going to be congruent to the 40 degrees, so we know that angle C is going to be 40 degrees. So I'm going to go ahead and write that there. 40 degrees, that's the degree we're working with here. All right, I think I'm kind of cutting close on time here. Oh wait, I was getting it confused with next period, getting off at the 17, not 27. That's my bad. Okay, but we have the 40 degrees, and we also know that Pedro is 30 feet up in the air in the wood-carved dog inn. But using that information, now we can start applying the ratio in, well, not applying the ratio. We need to find the ratio in order to solve for that distance we're looking for. So if we have our 40 degrees and we also know the height of the dog, we also need to, let me make sure I know what we're solving for here. It's going to be, what is it, horizontal? Okay, horizontal distance. Let's get myself tripped up. So we're looking for DC. If we have 30 feet, what ratio are we going to be using for it? If we have that 30 feet right here, but we are solving for the horizontal leg, what ratio are we going to be using? Cosine? Okay, so why cosine? Is DC, is that going to be a leg? Well, or is it going to be the hypotenuse? It's adjacent. Okay, so if 30 feet is the opposite, but we're solving for the adjacent side of a triangle because of the degree and where it's at, if it's opposite and adjacent, what ratio are we going to be using? Tangent, exactly. So we have our tangent. We have our tangent. What degree are we using again? 40 degrees. So we have tangent of 40 degrees. And then what is our ratio going to be? Again, opposite over adjacent. So what's that ratio going to be? 30 over x, exactly. So this is kind of similar to that problem we did earlier. We have the x on the bottom now. What's the first step that we're going to do? If we're divided, we got to multiply. But what are we multiplying? X, yes. So we're going to bring that x over. It's going to be that tangent, or excuse me, x tangent of 40. Set that equal to 30. Again, this is just like that first problem we did, or that one of those first problems that we did earlier. If we're multiplying all that together, what are we dividing? Tangent 40. Yeah, we're dividing that. So again, in your calculators, this is what I want you to put. I want you to put 30 divided by, and then I want you to put a parenthesis. Again, we need the calculator to solve for tangent of 40 first. So again, we're doing 30 divided by a parenthesis, and then the ratio tangent, or yeah, the trigonometric ratio tangent. And then I want you to type in the number 40, and I want you to put 2 parentheses right after that. And then after typing that in, what number are we getting? Someone from this side of the room. What number are we getting? Who did the calculation? Yeah. 35.8. Yeah. 35.8. Is that the final number that we're working with? No, why is it no? Rounded to the nearest foot? Okay, yeah, that's true. But do we need to add anything else to it? No, yeah. Because we're just looking for that distance or that horizontal distance. There's nothing else that we needed to add to it. But yeah, no, that is the number we're looking for. Again, we just had to round it, but that. But yeah, no, sorry. Any questions on that? No questions. All right. Let's see here. Okay. I do have one more example. It might get a little tricky, so just bear with me on it. Does everyone have this written down before I move on? Okay. All right, cool. All right. Okay, so for this one, using 2 angles of elevation or depression. Okay, so we're at a mall. And then Well is estimating the height of the second floor in the mall. She sights the second floor at 10 degrees at a 10-degree angle of elevation. She then steps forward 50 feet until she is 5.5 feet from the wall and sights the second floor again. I don't know what, hang on. Oh, there it is. If Wells' line of sight is 66 inches above the ground, at what angle of elevation does she sight the second floor? Okay, so what we're doing here is we are solving for y. That's what we're going to be solving for. There's a lot of information into this, so the first thing you need to do, look at it, just like you need to take just a deep breath, let it all out, because it is a lot of information. You just got to have a clear mind when you're looking at this sometimes. So the first thing that we're going to do is we need to solve for the height. We are solving for 2 things. We're solving for the height of the second floor, so that AB, and we are also solving for that angle of y. I started off solving for x first because x comes before y, so I solved the y first. So using y, think of it as a big triangle. Forget that middle line. We're not even worried about the middle line right now. So we're solving for x. I'm just going to kind of emphasize that x right there. Because we're solving for the big triangle, we need to first find out all the information about that big triangle. So if we're looking at triangle ABD, we'll just do it like that. What is going to be my bottom length of DB? 55.5, exactly. So why are we using 55.5? Exactly. We need to take all that information because we have our 50 feet right here, but we also have that 5.5 feet. So that whole thing is going to be 55.5 feet for the bottom part of that big triangle. Yeah, that's exactly right. Okay, again, so we're working with that 10 degrees right there, right? If we have our 10 degrees, we have our 55.5. If we have our 55.5, but we also have our x, which is going to be opposite of the angle, what ratio are we going to use for that? I heard it. Tangent, y tangent. Exactly, we were working with the opposite as well as the adjacent. So we need to go ahead and set up that ratio. So if we have tangent of, oh, that's a bad A. All right, if we have that tangent of 10, we set that equal to x. Sorry, not x. What's the ratio going to be at that point? Again, opposite over adjacent. Yeah, exactly. Because it's going to be opposite over the adjacent. So x over that. Oh, there you go. Tell you what, 5s are so hard to draw or write sideways. But yeah, it's going to be opposite over the adjacent. So x over that 55.5. And now we are going to bring that over, right? Whatever's on the bottom, we bring it over because it's dividing, so it would be multiplying. So that is going to give us that 55.5 tangent of 10. We're going to set that equal to x. Now I want you to go ahead and plug that part into the calculator, the 55.5 tangent 10, and then when you're done, I don't care, just someone shout it out or something. I really don't care. Sorry, what? 9.7? Is that what we're getting? Okay, 9.8. 9.8. Is that what we're getting? 9.8? Yeah, seeing a lot of head nods. Okay, cool. So if we have our 9.8, let me double check here. We have our 9.8. Let's see. Are we all the way done? No. Why are we not done? Solve for the right. Oh, okay. That's my bad. Just for x. Are we done? Are we done with the height? If it's 9.8, are we fully done? No. Why are we not done? Exactly. We have to add the 5.5 feet. Or wait, no. Hang on. Sorry. This 66 inches because of the height of the person. So then we would have to convert 66 inches into feet to solve for the overall height for it. Ooh, getting close on time there. Okay. Here, that's what we would do. Let's just solve for y real quick. But in this case, what you would do is you would take the 66 inches, convert it to feet, and then you would add it to the height of x. That's what we would do for it. Well, but yeah, no. Are there any questions on that? Feel good? Okay. Well, we can go over that tomorrow real quick. But homework is. Okay. All right. But yeah, homework. It's gonna be it's not due tomorrow. It's gonna be 2 days. But yeah,